Hello everyone, and thank you for tuning in to another installment of I Excel and So Can You. Today I wanted to begin a discussion on a widely debated topic relating to infographic design, concerns the use of circles and pie charts. For the most part, I will be taking up the position that these type of illustrations should actually be avoided by first providing some examples of potential flaws that these type of graphics pose. And then in later videos, I'll have a couple videos dedicated to demonstrating and showing unique alternatives to these all too common graphics. Now, as a fair warning, unlike most of my other videos, this one will have little to do with Microsoft Excel and more to do with graphic design in a more general sense. And will mostly be presented using PowerPoint. Fair enough. Let's begin. So, what could possibly go wrong when using circles to express data? Well, for one thing, it turns out accurately comparing sizes may be more difficult than you'd expect. For example, say I raise the question, which of these two orange circles is largest? How about now? How about now? How about now? And I think you get the point. In this famous illusion called the Ebbinghaus illusion, forgive me if I'm mispronouncing that. Now, I probably could have done the same trick using other shapes. However, the point is, currently the most popular shape used to compare volumes, typically via shape area comparison, for some reason is circles. Imagine if this example here was a bubble chart, one of the easy default chart options in Microsoft Excel. Simply due to the coincidental bubble positions, end users might come up with the wrong conclusion. Here's another example just to show you that all potential flaws aren't entirely due to known optical illusions. Say you're looking at this actual bubble chart here. If you had to choose, assuming that the areas of these circles represent the profits of 5 different companies, and you were given the option of either receiving the profits of company A or receiving the combined profits of the other 4 companies, which would you choose? It's not an easy question. Besides the fact that technically you have a 50-50 chance of randomly getting the right answer. I'll give it a couple more seconds. You can pause the video if you want. Answer, as it turns out, the area of circle A is in fact greater than the combined areas of circle B, C, D, and E altogether. And unlike the last one, this is not a famous illusion. The problem is people just aren't good at calculating and comparing areas of circles on the fly. It's not because we're dumb. I assume everyone is aware that the area of a circle equals pi, 3.14159, so forth, times the radius of the circle squared. And given enough time, a ruler, maybe a calculator, I bet just about everyone could have figured out the answer eventually. But having the end user maybe eventually coming up with the desired conclusion isn't supposed to be the sought after goal of an infographic, now is it? Here's another real quick example, sort of along the same issue lines. Say that the area of the smaller circle is 1 unit. In that case, what do you suppose is the area of the larger circle? Now, I have asked other people to do this, and so have the people who I originally got this slide from. And we have both gotten answers ranging from 6 to 50, which is a pretty wild margin of error for a graphic that is assumably supposed to be super simple. Spoiler alert, the answer is 16, okay? But how about a real world example of things going wrong? Here we have a screenshot from one of President Obama's State of the Union addresses with a small piece temporarily being redacted by yours truly. Now, judging by this screenshot, what would you guess was the USA's GDP in 2010? did you guess 14.5 trillion? Maybe, maybe not. Here's one reason why many of you may have gone wrong. So, if the US's GDP was in fact 14.6 and China's is 5.7, that means that the US GDP is 2.5 times larger than China's. However, visually, as you can see here, it's fairly easy to visualize more than 4 China circles easily fitting within the US's single. So does this mean this infographic is a lie? Well, if we look at this graphic a bit more carefully, we can determine that the diameter of the US's circle is approximately 98 pixels in diameter. If you try doing this at home, you might get a different answer. I had to tweak the actual size of the screenshot here, so at some point it was 98, and that goes on for the rest of this presentation. And China's was 40. 98 divided by 40 is about 2.5, or 2.45. The problem is, I'm guessing very few of you were comparing the circles based off of their diameter. Instead, as we have been taught in school, we were comparing by the circle's areas, which would have given you this result here, where the US is 6 times larger. And had the graphic designer wished for us to compare the circle areas by circle area instead of circle diameter, suggests that the circle should have been approximately 64 pixels to China's 40. Now, this confusion in desired means of data interpretation begs an important question from my loving Excel enthusiasts. So what are we supposed to be comparing when we use Excel's bubble chart? Well, if you create a table like this one, select all of the cells and go to Insert, Other Charts, 2D Bubble Chart, you should get a chart that looks something like this. And if you go through the trouble of measuring the diameters of these circles, you find basically Excel expects us to compare the circles' areas, and not their diameter. So it seems kind of odd, almost suggesting that our government went out of its way to deceive us. That the fact that prior to this speech, the White House had recruited such famous infographic gurus as Edward Tufte, revered by some as the father of data visualization, writer of such books as Beautiful Evidence, and not to mention staunch pie chart abolitionist to improve data communication. The same person that popularized the opinion that scaling a variable by a single dimension, like a circle's diameter of a 2D shape, is a bad idea, basically. So yeah, it's a bit strange, but does this mean that the president went out of his way to mislead us? I don't know. From watching Wonder Why's first video on winners and losers, I do know that this wouldn't be the first time that the government has actively massaged the truth in order to make us look more relatively powerful compared to China. According to him, both the UN and the CIA, in their official record keeping, apparently have biased the recorded land area of the US compared to all the other countries by counting coastal waters and territorial waters only for the US. For everyone else, they don't get that extra credit. How that impacts our total size, you'll have to watch this video. But anyway, this all just is kind of odd to me, but at the same time, it's also quite beside the point. As far as this video is concerned, what's important here isn't whether or not this chart was intentionally misleading, but more importantly, is this chart could be misleading or ambiguous. And if a chart doesn't clearly and effectively communicate its desired message or results, then what's the point of having the chart in the first place? And as far as best practice is concerned, when deciding on the type of chart to use, can anyone tell me how this type chart works better than this? Now, do you think you would have had the same trouble interpreting the chart areas as you did when I blanked out that one section 4 slides ago? As it turns out, a lot of the time when you might be tempted to use a circular chart like a bubble chart or a pie chart, you may very well be faced with a situation where a bar or column chart would actually be a lot more effective. Just something to keep in mind, and something I will be demonstrating in later videos. Now, at this point, you may be saying, okay, so maybe you've made an interesting case against evil bubble charts, but please do not touch my poor innocent pie charts that we all love so very much. Well, in which case, I'm sorry, but from here on out, I'm pretty much going to be focusing on taking your precious pie chart down a peg, as this graphic clearly shows. But first, I'll go ahead and recognize the pie's strengths. A pie chart's main strength is its implicit, quote-unquote, part of the whole relationship message. One thing everyone understands when looking at a pie chart is that all of the pieces are in some way interrelated and collectively amount to an exhaustive list of all things within that relationship. Fair enough. And also, secondly, it's familiar. Somehow, it has admittedly become widely adapted almost unanimously, possibly due to the fact that so many children are taught their fractions via looking at different pieces of pie slices, sliced in various ways, namely quarters, halves, and so forth, which may actually partially explain my bias against them due to the fact that I learned my fractions growing up using these. Go unit blocks. Yeah. With that said, the pie chart also has several things going wrong with it, at least effectively, or at best, I will be demonstrating in later videos how the message displayed in a pie chart might actually, and most likely, would be better demonstrated using some form of a bar chart. Stay tuned. Thank you for watching. If you like this video, please give me the thumbs up, possibly subscribe. Everything helps. If you have any questions or comments, please include them. I do my best to respond to as many as I can. And thank you so much for watching. Thanks. Bye.